Hello everyone, this is part 2 of the 2.5 lesson on zeros of a polynomial function. Enjoy! Alright, to begin this lesson, let's take a look at the fundamental theorem of algebra. If f of x is a polynomial of degree n, where n is greater than or equal to 1, then the equation f of x equal to 0 has at least one complex root. What that means is that this equation, f of x equal to 0, will have at least one complex solution. So it could be a real solution, it could be an imaginary solution, or it could be both, but it will have at least one complex root of a plus bi form. Let's take a look at some properties. If r1, r2, r3, and so on and so forth are the roots of a polynomial equation, then you're going to have a factor, x minus r1, another factor, x minus r2, and so on and so forth, equals 0. Now, this makes a lot of sense, because if we plug, let's say, r1 into this x right over there, what we have is this will be r1 minus r1, which will be 0, which will cause this whole left-hand side to equal to 0, which is what we want. So this makes a lot of sense. Okay, now let's look at number 2. If a polynomial equation is of degree n, then the equation has n roots. This is very important because this tells you how many answers you should have each time you solve a polynomial equation. If the polynomial equation is of degree 3, then there should be 3 answers. If it's degree 4, then there should be 4 answers. Now, if you have an answer in the form a plus bi, then a minus bi will also be a root. Likewise, if a plus root b is a root, then a minus root b will also be a root. The best way to really see how this all unfolds is to just dive right into an example. So let's look at an example here. Alright, this example says, find the polynomial of minimum degree with zeros 5 and 2 plus 3i, and f of 0 equals to 130. So the first thing we're going to do is we're going to take this 5, which tells us that x minus 5 is a factor. Then we take this 2 plus 3i, which tells us that x minus 2 plus 3i is a factor. However, it's very important that you put 2 plus 3i in parentheses, because that is a two-term expression that needs to stay together. Okay, now, if you look at number 3 above, it says if a plus bi is a root, then a minus bi will also be a root. So this tells us that we also must have x minus 2 minus 3i as a root. Okay? And so this third factor comes as a result of property number 3 above. Okay? All right, now at this point, we're going to distribute this minus sign into the 2 plus 3i, giving me x minus 2 minus 3i, and likewise over here, I would have x minus 2 plus 3i. At this point, we also must put an a over here in the front, because there is possibly a leading coefficient right here in the front that wouldn't affect these factors as far as these being the zeros, but this could play a role later on. So we're going to put a coefficient of a right there in the front. All right, now at this point, you have several options on what you can do. I'm going to show you the longer way first, and then I'll show you a faster way later on. Okay? All right, so here's the longer way. You have to distribute these 3 terms to these 3 terms, and it's going to result in a really long 9-term expression. So you have to be extra careful. Okay, I'm going to draw arcs so that you know each step here. X times x is x squared. X times negative 2 is minus 2x. X times 3i is plus 3ix. Then I'm going to change colors so that you can see the second part now. Negative 2 times x is minus 2x. Negative 2 times negative 2 is plus 4. Negative 2 times 3i is minus 6i. I'm going to use one more color. I'll use black. Negative 3i times x is minus 3ix. Negative 3i times negative 2 is plus 6i. And negative 3 times 3i is minus 9i squared. All right, close that parentheses, equal to 0. Now notice we have 9 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9. Some of these terms will cancel. So you can see that 3ix and minus 3ix cancel. Minus 6i and plus 6i cancel. So now we have x squared. There's 2 of these minus 2x's. So minus 4x. You got a plus 4 right over here. And then over here, you have a minus 9i squared. And I squared is negative 1. So then you really have a plus 9. Because negative 9 times negative 1 is plus 9. So I have a plus 9 over here. Then I have a times x minus 5 times x squared minus 4x plus 13 equals 0. Now at this point, let's plug in 0 for x and set it equal to 130. So I'm looking at up here so that I can solve for a. All right, so a times, again, I'm putting 0 in for x. 0 squared minus 4 times 0 plus 13 equals to 130. Okay, because up there, f of 0 is equal to 130. So if a times negative 5 times 13 equals 130, so I have negative 65a equals 130, giving us a equals negative 2. Now that I know a is negative 2, instead of writing a, I'm going to write negative 2 in place of a. So going back up to this step right here, I now put in negative 2 in for a. So I have negative 2 times x minus 5, x squared minus 4x plus 13. Okay? Now that's my polynomial here. I just need to do a couple more steps of simplification and I will be done. So f of x equals negative 2. So I'm going to distribute this x minus 5 to this. Now, when I do, I get x cubed minus 9x squared. And then I also get, let's see, plus 20x plus 33x. And then you have minus 65. Now I'm going to distribute the negative 2 in, and I get negative 2x cubed plus 18x squared minus 66x plus 130. And this is my polynomial function. So let's take a look at this whole problem as a whole. Now there is one shortcut that some people like to do when they do these types of problems. And so I'll show it to you right now. I'm going to take this step right over here, the part that I'm highlighting in red right now, and I'm going to kind of break that off onto the side to show you an alternate way of simplifying this part that I'm highlighting in pink. So I'm going to take this out on the side. I'm going to draw a box here to kind of separate out this section to show you an alternate way. All right, so let me start off by just rewriting this problem. X minus 2 minus 3i, x minus 2 plus 3i. Okay, so the key to this one is to group the x minus 2. So I'm going to put that in black parentheses. Now what you see here is something in the form m minus n times m plus n. So it's like me saying m is x minus 2 and n is 3i. All right, we know that when we do m minus n times m plus n, this is multiplying two conjugates. And when you multiply two conjugates, you get m squared minus n squared. So that's going to be the shortcut. All right, so what I have here is x minus 2 squared minus 3i squared. Okay, now x minus 2 all squared is x squared minus 4x plus 4. And then minus 3i all squared is 9i squared. And then you have x minus 5 times x squared minus 4x. And then this part, minus 9i squared, with I squared being negative 1, will give you 4 minus 9 times negative 1, which will give you plus 13. And take a look at this. I'm going to highlight this last step in red, or let's highlight it in green. Look at this x squared minus 4x plus 13. That's the same as what we have over here on the left side, x squared minus 4x plus 13. So basically, what's in this red box is another way of arriving at x squared minus 4x plus 13. The important thing is that you choose the way that you're more comfortable with. Method number 1, you distribute these 3 terms to these 3 terms, getting these 9 terms, and then you simplify. The second method is to group the x minus 2 so that you see this m minus n times m plus n pattern, which results in m squared minus n squared. So some people consider this to be a little bit faster, a faster way of getting to x squared minus 4x plus 13. But it's up to you, because they both arrive in the same step, and then after that you continue with the rest of the problem. Okay? Alright, now you're going to try a problem on your own. So in just a moment, you will be pausing your video. When I say so, do the problem that I'm about to show you, which is over here. And then after you unpause the video, the solution will appear. So pause your video now. Alright, here is the solution. F of x equals negative 3x cubed minus 3x minus 30. This polynomial has negative 2 as a 0, 1 plus 2i as a 0, and 1 minus 2i as a 0. And it also holds the property of f of 1 equals negative 36. Now, in your lesson notes, I want to see the work that leads to this answer, so that I know that you actually worked it out instead of just wrote the answer down from this video. Okay? So I expect to see the full work shown to arrive at this polynomial. Alright, the last thing I want you to do for this video lesson is to practice a problem from part 1 of this lesson. So this problem is like the first part of this lesson, where you have to find the zeros given the polynomial. So in just a moment, I want you to pause the video, and then when you unpause it, you will see the solution. Go ahead and pause the video right now. Alright, here are the 3 solutions. Negative 2, 1/3 plus root 5 over 3i, and 1/3 minus root 5 over 3i. Alright, like the previous example, I will be expecting to see your work with this problem. Not just the answers, but I want you to show your work so that I can see that you actually worked it out. Alright, hope you got this right answer. I'll see you guys all in class. Bye-bye.